Hi friends, today I am giving a lecture on example problem on a priori algorithm. In the previous video, I am discussing one example problem on a priori algorithm. In that video, I am discussing another example problem on a priori algorithm. Mainly, a priori algorithm is used for finding out the frequent item sets from the given transactional database. Okay, so now this is the given transactional database. It contains two columns. First column represents the transaction ID and second column represents the item IDs. Okay, in the transaction ID, the transaction numbers are there from 100, 200, 300, 400, 100 to 400. And in the item IDs, what are the items that are purchased by a particular customer in a particular transaction? So here item ID 1, 3, 4 are purchased in transaction ID 100. In transaction ID 200, 2, 3, 5 items are purchased. In transaction ID 300, 1, 2, 3, 5 items are purchased. In transaction ID 400, 2 and 5 items are purchased. So this is the given transactional database D, and minimum support count is equal to 2. So these are the inputs for the given problem, that is example problem on a priori algorithm. First, scan the database, scan the transaction database for support count of each and every item. So here there are 5 items are there, 1, 2, 3, 4, 5. So these are the 5 items are there. So how many times each item is there in the given transactional database? So here, so candidate item set 1, that means the item set contains a single item. How many times that can be there in the transactional database? So that is represented by C1. In that C1, item set and support count. Okay, so first 1, how many times 1 is there in the transactional database? 1, 2 times. Okay, next, how many times item 2 is there in the transactional database? 1, 2, 3 times. Next, how many times item 3 is there in the transactional database? 1, 2, 3 times. Next, how many times item 4 is there in the transactional database? Only 1 time. Okay. Next, how many times item 5 is there in the transactional database? 1, 2, 3. So 3 times. Okay. So there are 5 items are there. So each and every item, how many times is present in the transactional database? Okay. Once we are getting C1, now compare the candidate support count with the minimum support count. Okay. If the candidate support count is less than minimum support count, we have to prune that candidate item set. If the candidate item set item support count is greater than or equal to 2, that can be exist in the C1. Okay, so here first item set 1 support count is 2 is greater than or equal to 2. So as true, it is exist in the L1. Next, item set 2 support count is 3 greater than or equal to 2. Condition true. So it is exist in the transactional database. Next, item set 3 support count is 3 greater than or equal to 2. So as condition true. Now it is exist in L1. Item 4 support count is 1 is compared with 2, 1 less than 2. So it can be pruned from C1 So that is not there in L1. Next, item 5 support count is 3. 3 is compared with 2. So 3 is greater than or equal to 2. Now it can be exist in L1. So in the L1, whose item set support count is greater than or equal to 2, that item sets are only present in L1. The remaining item sets are pruned from L1. Okay. Next one. Once we are getting L1, generate C2 from L1. C2 means candidate item set 2. That means each item set contains 2 items. Okay. So here 1 is combined with 2. We are getting 1 comma 2. 1 is combined with 3. We are getting 1 comma 3. 1 is combined with 5. 1 comma 5. 2 is not combined with 1. Okay. 2 is combined with 3. We are getting item set 2 comma 3. 2 is combined with 5. We are getting item set 2 comma 5. So 3 is combined with 5. We are getting item set 3 comma 5. So how many times it is exist in the transactional database? That means we have to find out the support count of each and every item set. Next, first one, 1 comma 2. How many times 1 and 2 items are purchased together? 1 comma 2 it is not there. 1 comma 2 it is not there. 1 comma 2 is present one time. So here 1 comma 2 is only one time it is present. Okay. Next one, 1 comma 3. How many times 1 and 3 items are purchased together? In the transactional database, 1 comma 3 one time, 1 comma 3 two times. So here this is 2 times. Next, 1 comma 5. How many times 1 and 5 items are purchased together in the transaction database? Only one time. Yes. Next, 2 comma 3. How many times items 2 and 3 are purchased together in the transaction database? One time, two times. Next, 2 and 5. How many times 2 and 5 items are purchased together in the transaction database? 2 times. 3 times. 1 time, 2 times, 3 times. Next, how many times 3 and 5 items are purchased together in the transaction database? 1, 2. So 1, 2. Okay. After getting C2, these are the support counts of each and every item set. Next, once we are getting the item set support count in C2, compare the item set support count with minimum support count. So it is less than 2. It can be proved from the L2. Next, it is less than 2. It can be proved from the L2. Next, the remaining are. So 1 comma 3 is existing. 2 comma 3 is existing. 2 comma 5 is existing. 3 comma 5 is existing. In L2, what are the item sets are present? The item sets whose support count is greater than or equal to the minimum support count that are present in L2. Okay, 1 comma 3, 2 comma 3, 2 comma 5, 3 comma 5 item set support counts are greater than or equal to 2. So that they exist in L2. Next one. Next, generate C3 from L2. Okay. So generate C3 means the candidate item set contains 3 items that can be generated from L2. Okay. So here, by clubbing these 2 item sets, one item is combined compulsory, but combining. Okay, 1 comma 3, 2 comma 3. Here 3 is combined between them. So by clubbing these 2 item sets, we are getting 1, 2, 3. Next, 1 comma 3, 2 comma 1 comma 3, 3 comma 5. By clubbing these 2, 3 is common between them. By clubbing, we are getting 1 comma 3 comma 5. Next, 2 comma 3, 2 comma 5. Among them, item 2 is combined. Item 2 is common. By combining them, we are getting 2, 3, 5. Next, remaining, there are no other item sets. Okay. Now, once we are getting candidate item set C3, find out the support count of each and every item set from the transactional database. Here 1, 2, 3. So 1, 2, 3, 1, 2, 3. Here 1, 2, 3. 1, 2, 3 only one time is there in transaction ID 300. So its support count is 1. Next one, 135. How many times it can be present in the transactional database? 135. Only one time it is present. Okay. Next, 235. How many times 235 items are purchased together in the transactional database? One time, two times. So 2 times. Okay. Once we are getting the candidate item set C3 with the support count, that it can be compared with the minimum support count whose candidate item set is support count is greater than or equal to 2, that can be exist in L3. So this item set support count is 1, it is less than 2, then it can be pruned from L3. Next, 135, its support count is 1. So its support count is less than or equal to the minimum support count. So then it can be pruned. Next, 235, its support count is greater than or equal to the minimum support count. So it can be exist in L3. Now, L3 contains only a single item set. So that is set of 2, 3, 5 whose support count is 2. It satisfies the minimum support count condition. Now, so from L3, so we are generating C4, but there is no candidate item set. There is no candidate item set we are getting from L3. Okay, so therefore C4 and L4 is equal to pi. So whenever C suffix k and L suffix k is equal to pi, a priori algorithm is terminated. Then the item sets in the L suffix k minus 1 are frequent item sets. Here C suffix 4 and L suffix 4 are pi, that is null set. There are no item sets are there in C4 and L4. So hence the item sets present in the L suffix k minus 1, that is L3, are frequent item sets. So in the L3 only one frequent item set is there. So that is called as frequent item sets. Therefore the frequent item set is equal to set of 2, 3, 5. So this is the description about example problem on a priori algorithm. So thank you for watching this video. If you like this video, please subscribe my channel name. So Divvela Srinivasa. If you like this video, please share this video to your friends and classmates. Thank you.